Alright, in this calculus lesson, let me give you guys a summary on the bad limit forms, aka the indeterminate forms for limits. And these are the forms that when you are dealing with limits, and if you see them, unfortunately, we cannot draw any conclusion yet. It means that we have to do more work in order to figure out the answer. The first one, perhaps the most famous one, is 0 over 0. So if we go back to our previous examples, when we see 0 over 0, yes, it could be equal to 1, but you see that this is also 0 over 0, but this limit gives us 1/2. So really we have to do more work in order to figure out the answer. And 0 over 0 is perhaps the most important one during the first half of your Calculus 1 class. Then next, I would also like to put down another one that's in the fraction form, and that's infinity over infinity. And that's why we talk about it in the previous video, like this. Then we have 1 to the infinity's power, and yes, this is an indeterminate form. The answer to this is not necessarily equal to 1 when we're dealing with limit. And we have an example right here. The classic example, when we have 1 to the infinity's power, this limit actually turns out to be e, which is approximately 2.718 something. So when we see 1 to the infinity's power, remember this one here is not exactly equal to 1 when we're dealing with limit. Alright, so all these are the limit indeterminate forms, and then we have one more that we have dealt with so far, and that is infinity minus infinity. The answer is not necessarily equal to 0. Yes, we have an example that we did right here. This one, infinity minus infinity. The answer we end up with is 4. Alright, so far we have seen 4 indeterminate forms, but how many are there? Well, I'll tell you, we have a lucky number of 7 of them. So let me just give you guys the other 3. Alright, here's another one. 0 times infinity. Wait, isn't 0 times anything 0? But not when we have infinity. When we're dealing with limit, no, it's indeterminate. And then if we have 0 to the 0's power, the answer to this is not necessarily equal to 1. Again, we will have to do more work in order to figure out the answer for the limit. Lastly, well, is 0 to the infinity's power an indeterminate form? No, in fact, you can draw a conclusion that this thing will approach 0 for sure. So I'm going to call this kind of form good limit form. And I'm going to give you guys a summary for that after the bad limit indeterminate forms as well. But for now, there's one more. Which one? Well, if the base is infinity and then raised to the 0's power, sorry, we don't know what the answer is yet unless we do more work. And there you have it. This is the 7 indeterminate forms. Now, let's actually talk about the good limit forms. And I don't think there's a proper term for this, or like an official term for this, but I'm just going to call them good limit forms, because this right here, you actually get to draw conclusions right away. So let's talk about the first one. When we have 0 over 0, it was the bad limit form, right? I'm going to change this a little bit. Suppose I have a non-zero number on the top over 0. In fact, when we are dealing with limits, this is not undefined. You get to draw conclusion. Either we get positive infinity or negative infinity. One or the other, never both. You never write down plus or minus infinity for a limit question. So it's either or, never both. And what you will have to do is you will actually have to check the sign. If it's positive divided by negative, things like that. And let me also give you guys another one, similar flavor. Let's take a look at infinity over infinity. This was a bad limit form. But if you have infinity on the top over a finite number, which is non-infinity, you also get to draw conclusion. Either you get infinity or negative infinity. It really depends on the sign. If this is positive divided by negative, then you get a negative infinity. So again, you check sign. It's either or, never both. And now let's flip them around. Suppose I have a 0 on the top and then divided by a non-zero number. Well, let me tell you, you always get 0. Don't say plus or minus 0, it's just 0. So you see, you get to draw conclusion right away. And if you flip this around, then we will have a finite number on the top divided by infinity. Guess what? You can also draw conclusion right away. You get 0. Alright, let me also talk about this one, but not the zero's power, but rather, let's say if we have positive number versus negative number for the power. So let's have a look right here. Suppose today you have infinity. Let's say you raise this to a positive number. Let's say positive 0.1, then that's okay. But not 0, okay? Let's say 2 or 1/2, okay? You can draw conclusion. This is going to give you infinity. Of course, I'm assuming that this is positive infinity and positive number infinity, right? And if you have infinity, but if the exponent here turns out to be a negative number, well, negative power means that you just bring this down to the denominator. So it turns out to be this situation, right? You get 1 over infinity and you can get 0. Yeah, again, you can draw conclusion right away. So if you just go back to the indeterminate forms here, and then just try to take a look at one or the other. Like for example, I can give you guys another one right here. 1 to the infinity's power, I can also break it down for you guys. That's an exponential part, right? So here's the deal. If today you have a base, so let me just put this down as base in red. Any base greater than 1, if you know for sure it's a solid base that's greater than 1, and then raised to the infinity's power, guess what? You get to draw a conclusion that will go to infinity. And if you have the base that's actually in between of 0 and less than 1, including 0, so 0 to the infinity's power, right? It's here. You get to draw a conclusion that this right here will go to 0. If you have 1/2 raised to the infinity's power, you get to say that it's equal to 0. So in fact, this is just like a consequence of this one, because when you have 1 over 2 to the infinity's power is like a finite number over 2 to the infinity power. Yeah. Alright, so that's pretty much it in terms of like how you turn the bad limit forms into good limit forms. So I will just give you guys these 8. And of course, in your calculus 1, you will also be dealing with other function. So let me also tell you guys some honorable mentions. So I will just put down note. If today you are dealing with an inverse tangent, let me just actually go down right here. If you have infinity inside, and what I'm trying to say is, I'm really trying to say the limit as x approaching infinity of inverse tangent of x. Alright, so this is just a notation for this thing. A lot of people don't like it, but it helps you to draw conclusion right away. Remember this? This gives you pi over 2. Why? Because we did them already. We did this kind of questions already right here. Think about the graph. It's right here. It has a horizontal asymptote. Therefore, as x goes to infinity, we have a finite limit for that. Alright, let's go back and then let me give you guys a couple more. And again, let me not put down the limit notation here. Let's talk about if we have natural log. Guess what? The natural log of infinity. Natural log function does not have a horizontal asymptote. This right here goes to infinity. This right here goes to infinity. And then if you have sine, and if you take the limit as x goes to infinity, guess what? This right here does not exist because the sine function looks like this, right? It goes up and down in between of -1 and 1. It does not have a horizontal asymptote, so we do not have a limit as x goes to infinity. Similarly, cosine of infinity, this also does not exist either. Alright? And then I will also put this down right here. Natural log. It actually has a vertical asymptote. If the input here it turns out to be 0 plus, let me emphasize that, 0 plus. Let me put it down like this, 0 plus. This gives you negative infinity. Why? Because of how natural log function behaves. As x approaches 0 from the right hand side, you see that the function goes straight down. So this right here is that. And of course, it will be extremely helpful if you are familiar with all these kind of graphs, right? For example, the cosine graph looks like this. So that's why it doesn't exist. And then for sine, it goes like this. And this is y equals sine x, right? And perhaps I will also, yeah, I think it's pretty good already. So let me know if you have other questions, but this is it. These are the good and the bad limit indeterminate forms. And check out the next video. I'm going to show you how we can work out this kind of limit based on the good limit forms.